You're listening to the N2K Space Network.
Ever wished you could rebuild your network from scratch to make it more secure, scalable, and simple? Meet Meter, the company reimagining enterprise networking from the ground up. Meter builds full-stack, zero-trust networks, including hardware, firmware, and software, all designed to work seamlessly together. The result? Fast, reliable, and secure connectivity without the constant patching, vendor juggling, or hidden costs. From wired and wireless to routing, switching, firewalls, DNS security, and VPN, every layer is integrated and continuously protected in one unified platform. And since it's delivered as one predictable monthly service, you skip the heavy capital costs and endless upgrade cycles. Meter even buys back your old infrastructure to make switching effortless. Transform complexity into simplicity and give your team time to focus on what really matters, helping your business and customers thrive. Learn more and book your demo at meter.com/cyberwire. That's METER.com/cyberwire.
Today is December 16th, 2025. I'm Maria Varmazis, and this is T-Minus.
T-minus 20 seconds to LOS T-Drift. Go for deploy. Roger, roll. 5.
Momentus has successfully completed environmental testing of its Vigoride-7 orbital service vehicle.
4.
VAST is holding a call for ground-based and space-based research aboard Haven 1 lab and during potential private astronaut missions to the ISS.
3.
The U.S. Department of State is seeking qualified individuals to participate as private sector advisors for a discussion group on space situational awareness.
2.
EraDrive has raised $5.3 million in a seed round to scale the production of their space traffic management system.
1.
The United States and France held a joint orbital exercise as part of the multinational force Operation Olympic Defender. Our guest today is Trevor Smith, co-founder and CEO of Atomic 6. Trevor shared insights about why space microdebris risk is climbing and about Atomic 6's bulletproof space armor composite material that's designed to protect astronauts and critical space assets. Want to learn more? Well, stay with us after today's intelligence briefing. Happy Tuesday, everybody. Thank you for joining me. We're kicking off today's top stories with the joint orbital exercise held with the United States and France. The operation was carried out as a part of the multinational force Operation Olympic Defender. The nations conducted a bilateral rendezvous and proximity operation, successfully practicing joint maneuvers as part of U.S. Space Command's multinational space war plan. The mission saw two satellites maneuvering closely around each other in a way that can be used for various military missions, ranging from inspection to refueling to repair, or even to attack an enemy satellite. 6 allied nations are currently involved in Olympic Defender, and those nations are Australia, Canada, France, Germany, New Zealand, and the United Kingdom. The United Kingdom is the only other nation to have conducted a joint RPO with the United States. And while neither the United States nor its allies have made public the satellites that are involved in any of the joint RPOs, the private space tracking firm ComSpock said that the maneuvers with the UK involved a U.S. Geosynchronous Space Situational Awareness Program, or GSSAP, neighborhood watchbird. ComSpock also watched the Franco-American mission, which a company spokesperson told Breaking Defense involved another GSSAP spacecraft. And you know what? We're just glad to see cooperation on these missions, and long may it continue. California-based startup EraDrive has announced a $5.3 million seed round to scale the production of self-driving modules that allow satellites to maneuver autonomously using observational data. EraDrive was founded on a vision for a future where spacecraft could benefit from the onboard autonomy technologies developed at Stanford University Space Rendezvous Laboratory to enable applications such as APNT, space domain awareness, and rendezvous and proximity operations, all while feeding a space traffic intelligence layer on the ground to enable traffic coordination for large mega constellations. The company says it already has flight heritage, including TRL-9 results from the ongoing NASA Starling mission, and it's great to see SSA companies having their heyday. And Uncle Sam needs you to think more about space situational awareness. Yes, indeed. The United States Department of State is seeking qualified individuals to participate as private sector advisors for a discussion group on space situational awareness. The State Department says that individuals who are interested in participating in the discussion group should have experience working in the space sector, particularly in the areas of space situational awareness, space traffic coordination, and/or satellite operation, and be currently affiliated with a U.S. company, non-governmental organization, or academic institution that focuses on outer space research, technology, or activities. Selected participants will be added to a distribution list that will receive information concerning space situational awareness discussions within UN COPUOS, and that is the United Nations Committee on the Peaceful Uses of Outer Space, by the way, including meeting summaries, proposals, informational materials, and other related correspondence. More details about this solicitation and how to apply can be found in the link under the selected reading section of our show notes. And it is not just the U.S. government that's looking for input right now. Commercial space station company VAST is holding a call for ground-based and space-based research aboard Haven 1 Lab and during potential private astronaut missions to the International Space Station. The proposals are subject to award by NASA, by the way. Haven 1 Lab is scheduled to be the world's first crewed commercial microgravity research and manufacturing facility in space. VAST says it's aiming to enable innovative and technically excellent research on the world's first commercial space station, and the lab will be fully operational with highly capable facilities supporting automated and crew-assisted experiments. More details about the call for proposals can be found, yet again, in the link in our show notes. And Momentus has successfully completed environmental testing of its Vigoride-7 orbital service vehicle. The spacecraft is scheduled to launch aboard SpaceX's Transporter 16 mission, which is targeted for launch no earlier than March 2026. Vigoride-7 is scheduled to carry payloads for several customers, including the U.S. Department of Defense, NASA, and commercial customers. The test campaign included thermal testing, which simulated the extreme and temperature swings of space to validate spacecraft performance and reliability, as well as vibration testing conducted at Experior Laboratories, which exposed Vigoride-7 to the mechanical stresses of launch conditions. It does look like 2026 is going to be another busy year for payload launches. And that wraps up today's top 5 stories. Don't forget to check out the links to all of the original sources of all of the stories that I've mentioned throughout this episode in the selected reading section of our show notes. Just check out your podcast app for more. And hello there, T-Minus listeners. Pretty soon, we here at T-Minus will be attending Space Week in Florida. We will be at the Global Spaceport Alliance's annual summit, as well as Space Mobility and SpaceCom. Oh, and by the way, there will be a lot of moments from all of these events that we will want to share with you that just can't make it into the daily show. But we do post those moments on Instagram. We are at T-Minus Daily if you would like to see some exclusive videos on there, as well as some behind-the-scenes moments from the show floor. Hope to see you there. Our guest today is Trevor Smith, co-founder and CEO of Atomic 6. Atomic 6 is developing space armor composite material, and Trevor started our chat by telling me what's currently in use by the industry and why it needs improving.
So traditional systems, typically a Whipple shield, designed by Fred Whipple, started in the late 1940s. That's basically what we use to protect the International Space Station with. It is covered with Whipple shields, which are metallic shields, mostly metallic. They have some Kevlar composite, dry fabric in them. But basically, you have a standoff shield where it can be 4, 5, 6, 12 inches deep, and you have these plates of aluminum gapped by, call it 1 to 2 inches. And as that projectile comes in and hits the first layer, spreads out, hits the next layer, spreads out, hits the next layer, ultimately stopping the projectile before it gets, into damaging the ISS. Well, that's great because you've protected the ISS. But during that impact, we create additional debris through that impact. And from the videos we've seen in our own testing, more mass is actually ejected from that metallic plate than the original projectile coming in to hit it.
So if I'm understanding correctly, so it's actually creating more debris upon impact, essentially?
Yes, it actually creates more debris than the original impact. So you can see this video on the left side, we have space armor. On the right side is an aluminum monolithic block. This is a 3 millimeter projectile traveling at 7.2 kilometers per second, basically orbital velocity, what we see in LEO.
Yep.
And 1 million frames per second, because these are moving really fast. And so what you'll notice is on the left side, you see some gas and particulate coming out, but there's really no harmful debris, essentially because there's no metal in our shielding. It's an all-composite shielding solution. On the right side is a monolithic block of aluminum, and that is the rated thickness by NASA to stop the projectile, which it does actually stop the projectile. But in the video, you'll see there's additional debris coming out of the backside. Yeah. And that is because the energy shockwave is actually delaminating the aluminum, pushing that aluminum back towards whatever the spacecraft or thing that it was originally protecting from. So this video alone shows you there's a real potential snowball effect, the Kessler syndrome, for creating lots of debris in space unintentionally.
That's wild. I had never even considered that angle, like secondary debris being generated by debris impact. My goodness. So please tell me a bit about what you all are making, because it sounds really interesting.
Sure. So it's called Space Armor. We were having fun one night and we're like, wonder if the website spacearmor.com is available. We actually bought the website spacearmor.com.
That's often how it works, isn't it? It's like, is the URL available? Yes, get it.
So cool. So there was an SBIR topic that the United States Space Force put out through its SBIR program. And they said, we would like to see a new type of debris shield made. And so we applied for it. We're a composites company. And we said, well, let's see if we can figure this out. And so ultimately, through a few different iterations, we found an optimized layup for different composite material sets that can stop these projectiles moving at, Mach 21, 17,000 miles an hour. And we want to productize these so our customers can put them really anywhere they need to without really doing any additional engineering. And so one way we are approaching and have seen some traction in, we're building these in hexagon-shaped tiles. So we have them in 6-inch and 12-inch tiles. So the hexagon allows you to basically put each tile next to another one, covering the area that you really want to, without changing much on the engineering side. You literally can just use the adhesive to apply it to the outside of the spacecraft. And we have two versions of the protection. We have a radio frequency permeable version and a RF radio frequency blocking version. So to my knowledge, this is actually the very first radome ever built for space. There has been no debris protection historically that stopped debris and allowed radio frequency through it. And so one version of Space Armor can allow for that RF transmissive capability, which is really important because communications, your comm system, is arguably the most important piece of the spacecraft, because without comms, you're dead in the water, right?
Yeah.
So you have the RF transmissive and RF blocking, and then you have the light and max version. The light is 3 millimeter and the max is 12.5 millimeter. The light has gone through thermal vacuum chamber as well as vibration testing and also final impact. So we are finishing flight qualification now and should be through it in a few weeks. And I'll be happy to show you the one that's just got through all 3 of those.
Oh, this is cool. So for our folks who are audio only, he's holding up a tile on an aluminum plate, I presume. Looks like a vibration plate.
Yeah. So the aluminum plate was needed to mount it for vibration testing, but it has been through vibration, thermal, TVAC, and then you see the hole here, right?
Yep,
so
there's a big impact hole right on it. Yeah.
So this was the impact, and then the backside, there's
nothing.
Nothing.
It's clean.
Right. So that's typically what it will look like going on to a spacecraft.
That is awesome. Thank you for the props. Really appreciate that.
Sure.
And I'm curious. So you mentioned that there's some exciting things coming up. I imagine 2026 might be a busy year for you all.
Yes, we have a very busy year. We have our first flight, not with Space Armor, but actually our solar array product. A small demo version of that's flying up on, I think it's Transporter 16, pushed back to March, but it looks like March launch date. But with Space Armor, we have 2 customers that have signed up to fly it on the same launch in October. I think that's Transporter 17, something like that. But flying in October of 2026, 2 different customers, same launch. Really excited to see Space Armor go up and get that flight heritage that we've been working towards through the SIBR process, and then we got a tactical funding increase to get it through flight qualification, and now finally in the hands of some real world customers. So we're excited about that.
That is really exciting. Well, congratulations on all of that. Those are all huge milestones to have very close on the space scale. That's like practically tomorrow. So that's exciting. And I'm also curious, terrestrial applications of what you all are building. I imagine I can think of quite a few, but I'm curious what you all think.
So I'm not sure if you've been keeping up in the news lately, but directed energy has been one of the topics. And so we actually said, well, what would happen if we hit this with directed energy? Apparently it holds up really well. So there's not just space directed energy protection. So in space, you have, obviously debris protection and there's some directed energy protection offered as well with Space Armor. But terrestrially, because we can make this a radome, being able to protect your comms terrestrially from some sort of directed energy, system is very valuable.
Handy. Yeah.
Right. Could come in handy. And then when you look at things that travel terrestrially the same speed as what we see in LEO or close to it, we have a thought, and it is our idea that this shield should actually protect from small explosives. So think hand grenades, C4s, that kind of small explosive, where the projectiles are coming out around 10 kilometers per second. So 2.5 kilometers faster than what we're testing in space. But the performance curve of this shield should actually work. So we TBD, but we do believe it will also be applicable terrestrially across all domains. So whether that's maritime, ground-based systems, air-based systems, anything that you want to protect from small explosives or directed energy and just comms in general, the market, ironically, for Space Armor could be drastically bigger on Earth than it could be in space.
Dual use, it's the way to go. But it makes a lot of sense. Also, it so often that story plays out that way, and it's logical. It just is.
Yeah. Well, and another smaller opportunity, but I think nearly the most important. We are looking at applications to put hard armor into astronaut suits. So
really?
When an astronaut does a spacewalk, extremely dangerous.
Yes.
And so we would love the ability to put this into astronaut suits and help better protect our astronauts.
Yeah, I mean, thinking about it when we're talking about shielding, for spacecraft or space stations, when the astronauts do those EVAs, they are, as you said, extremely vulnerable. And I do wonder about what are we doing to help them out too. So there you go. You
and I were chatting earlier. Commander Chris Hadfield is a good friend and advisor, and I said, Chris, what is debris? How often is the ISS getting hit? And he said, it sounds like rain on a tin roof, which would terrify me if I'm doing a spacewalk, right? Like that is really terrifying.
Rain on a tin roof. That That is terrifying to hear.
Yeah.
Well, I mean, I knew they were brave as heck, but just
It's
add
probably not like, every 1 or 2 seconds, but it does get hit quite often.
I'm
I mean,
sure
you can
it does.
Google the pictures. It's littered with impact.
Oh yeah, they get peppered. It's just that's crazy. Wow. Well, I'm very glad that people are working on solutions for this, as I said, in many different directions, and it's just really cool to hear about what you all are building. Trevor, is there anything else you wanted to add to today's chat before we close out?
Yeah, we are updating our website to offer some sort of quote now options, different levels for space armor and RF or non-RF blocking and that sort of thing. So atomic-6.com is our website. And I live on LinkedIn, so if anybody wants to reach out on LinkedIn, I'm always on there and happy to answer any questions. And really just excited about the future of the company with launching our solar array product in March of next year, and then Space Armor going up with 2 customers on the same launch in October. So very excited.
We'll be right back. Welcome back. The way we talk about the moon sometimes, it just kind of gets a bad rap, doesn't it? It's inhospitable to life, has really irregular gravity, no atmosphere, no magnetosphere, covered in really clingy, messy regolith that just causes problems wherever it gets. Oh, and it smells bad too. Whew. But maybe we should consider that the moon's just doing her darn best, considering who she orbits. We're kind of a mess sometimes. If you think of Earth kind of like Pigpen from the Peanuts cartoons, raising a big old dust cloud wherever we go, and the moon's just kind of everybody else in those cartoons wheezing in our wake. Is that an exaggeration of reality? Yeah, absolutely. But is it completely far-fetched? Not entirely. There is new research from the University of Rochester that suggests that Earth's magnetic field has been quietly funneling particles from our atmosphere onto the moon for billions of years. So instead of acting purely as our protective shield against all the cosmic nasties, Earth's magnetic field has also been guiding ions knocked loose by the solar wind along field lines that, believe it or not, stretch all the way to the lunar surface. So yeah, that Pigpen dust cloud doesn't sound so silly now, does it? The U Rochester researchers studied computer simulations and Apollo-era soil samples from the moon and found that the ionic transfer worked best with a strong magnetic field. So this dust cloud comes from cosmically modern Earth and not our pre-magnetosphere past, which also could help explain why lunar soil contains unexpectedly high levels of volatiles like nitrogen and water, which are materials that the solar wind alone cannot account for. Indeed, perhaps over the eons, our very own Earth's been sending over some materials to the moon in a process called, logically, atmospheric escape. All this means that the moon may be a long-term chemical record of Earth's atmosphere, if you can believe it, serving as kind of a geological backup drive for our planet's climate and magnetic history. And for future lunar explorers, maybe the moon could offer more usable resources than we originally expected, potentially easing the logistics of long-term human presence just a wee bit. All thanks to our Earth's Pigpen dust cloud-like magnetosphere. And that's T-Minus, brought to you by N2K Cyberwire. We'd love to know what you think of our podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing space industry. If you like the show, please share a rating and review in your podcast app. Please also fill out the survey in the show notes or send an email to space@n2k.com. We are proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps space and cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am your host, Maria Varmazes. Thank you for listening. We'll see you tomorrow.
T-minus.